Dear student, welcome to the application series of application of partial differentiation. Today, here we will discuss properties of jacobian. So let's start property number 1. Okay, let's see the statement of property number 1. If we get u and v are the function of x and y, then del of u comma v upon del of x comma y multiply by del of x comma y upon del of u comma v is equals to 1. This is the statement of property number 1. It means that you have to given function u and v with variable x and y. Then first we calculate partial derivative of u v in terms of function with variable x and y. Then multiply jacobian of in terms of function x and y with variable u and v. You have to multiply these two jacobians, we will get the 1. Okay, now see the one example about property number 1. We have to given that if x is equals to u into v and y is equals to u plus v upon u minus v, then we have to say that find del of u comma v upon del of x comma y. Okay, now how to solve this type of example? See here, we have to given that del of u comma v upon del of x comma y. Okay, what is the meaning of that this term? Okay, this meaning of this term is we have to find the partial derivative of u with respect to x, partial derivative of u with respect to y, partial derivative of v with respect to x, and partial derivative of phi with respect to y. Okay, but we have to find these all four terms. uh, but here, look at here, you have to given function in terms of x and y, and variable in terms of u and v. But here we have to find del u by del x. This means that u is a function and x is a variable. We have to given in the reverse process. So first we will calculate here del of x comma y upon del x u comma v. What is the meaning of this term? This is also jacobian. Meaning of this term is del of x upon del u, del of x upon del v, del of y upon del u, and del of y upon del phi. Okay, comparison of these two terms, this term is very simple to calculate, because of you have to give one function in terms of x and in terms of y. That's why this term is very simple to calculate. Okay, now find this this term del of x comma y upon del of u comma v, which is equals to are in determinant form. Okay, first term is del u by del x upon del u, second term is del x upon del v, in second row del y upon del u and del y upon del v. Okay, what is the meaning, what is the partial derivative of x with respect to u? You have to given x is a u into v. X का derivative with respect to u is phi, and similarly partial derivative of x with respect to v is a u. Now second row, see carefully, meaning of this term is partial derivative of y with respect to u. What is, you have to given y is equals to u plus v upon u minus v, and we have to calculate partial derivative of y with respect to u. Then we have to use here u by v rule, then calculate the partial derivative. We have to get minus 2v upon u minus v whole square. Similarly here, derivative of y with respect to v, we will get the derivative same thing by using u by v rule. We have to given, we have to get 2u upon u minus whole u minus v whole bracket square. Now simplify this this determinant. We have to phi multiply by 2u upon u minus v square minus of u into minus of 2v upon u minus v square. Okay, here is the subtraction of these two terms. Okay, subtract this term, but here base is same, so I am right here u minus v into whole bracket square. Okay, now v into 2u is a 2uv minus this minus and this minus is plus 2 into uv. Okay, which is equals to 2 plus 2 is 4 u into v upon u minus v square. It means that we have to give one del of x comma y upon del of u comma v is equals to 4 into u upon u minus v whole square. Okay, but we have to find that how we have to find del of u comma v upon del of x comma y. So we use this property. Okay, so we use here this property del of u comma v upon del of x comma y multiply by del of x comma y upon del of u comma v is equals to 1. So I am writing here, we know what we know del of u comma v upon del of x comma y multiply by del of x comma y upon del of u comma v, which is equals to, okay, del of u comma v upon del of x comma y is as it is multiply by what is value of this, value of this is 4 into uv upon u minus v whole square is equals to 1. This is equals to 1 is property, right side of a property number 1. So I am right. Look at this 4 into u minus v upon u minus v, this term is multiply in the right hand side. I will taking this term to the right side, so denominator term is in the form of numerator and numerator term is going to the denominator. That's why del of u comma v upon del of x comma y, which is equals to this divide term going to this side, multiply 1 into this term is u minus v square upon 4 into u into v. This is a final answer of this question by using property number 1. Thank you, student.